Hello, and welcome to Season 2 of Tomversations. I'm your host, the networking nerd, Tom Hollingsworth, and each episode we like to have a conversation about a technology topic that might be of interest to some of you out there, take a deeper dive into some of the things that are going on in the industry. And today's conversation, I'd like to talk about zero trust security. At the end of 2020, we saw a massive amount of news stories about ongoing hacks, things involving crypto miners and breaches by nation state actors. Most everyone by now has heard of the SolarWinds attack. And there have been a lot of questions around how companies can secure themselves from these kinds of supply chain issues. Let's have a conversation about that. So as we delve deeper into what's been going on with the SolarWinds hack, there have been a lot of things that have started to surface that are worrying for people that rely on other vendors, other manufacturers to provide equipment or software for them. Supply chain hacks are a huge issue because we have to look at the ability of an attacker to insert software or hardware somewhere along our supply chain or into our process that we have no visibility into. How can I prevent someone else from getting hacked and causing me to be hacked along the way? These are questions that companies like Microsoft are currently asking, as well as agencies in the United States federal government who were indirectly hacked through SolarWinds. But the question that I have for you is, how do you know you're being attacked? Well, most people would say that they can detect attackers moving around in the network. They can recognize that people are trying to access things in an unauthorized manner. And that's a very interesting point to make, because it turns out that no matter how an attacker is capable of getting into your network, whether it's brute force or impersonating users or a supply chain attack, they all tend to take the same actions. They're either looking for something or they're trying to create a foothold and stay there a little bit longer. And that kind of movement, that kind of distinguishing characteristic is one of the reasons why security has started to develop around a zero trust model. And zero trust is a term that a lot of people have used in the industry recently to describe the idea that we, for so long, have had a very open security model around the way that we look at systems and users and software. So what is zero trust? Well, in a nutshell, zero trust is providing controls and continuous monitoring that allow us to provide least access privilege security to users and to devices. So in the old days, and I say the old days, it actually wasn't that long ago, we had this idea that you needed a very strong perimeter, some kind of a wall to keep the undesirable people out of your network, whether they're attackers or corporate espionage or people that just have no need to see the things that you are protecting. Unfortunately, the problem with walls is that as soon as you can breach one, you're on the inside and there's nothing to stop you. And then we looked to some of the traditional classification methodologies that are in use in places like the US federal government as a stepping stone, role-based security. Yes, you can get in through the front door, but unless you have a need to see something, it's not going to be visible to you. That's great in theory, but if I'm able to impersonate a user, that I can get around that particular control. And so that's zero trust security's basis. I'm not going to trust anyone to do anything until you prove that you are who you say you are. And then I'll only give you access to the minimum amount of things that you need to do your job. Zero trust is putting a nice big bow on a lot of other security focused concepts that we've been washing around for a while. But zero trust security isn't perfect. And there's a variety of reasons for that. The basic ones come down to the friction that zero trust security creates inside of an organization. Because when you're constantly having to prove your identity, you're constantly having to provide access codes or tokenization or some other kind of authentication mechanism to be able to access certain documents or certain websites. your users tend to get a little frustrated with you. Likewise, if you're trying to install a new software application or bring a new piece of hardware online, tuning those zero trust policies to allow it to speak and operate properly can be a little bit problematic. Anyone who's ever tried to open the right ports on a firewall to allow a device to communicate in and out properly without just creating an allow all rule knows this process. And most zero trust platforms have a monitoring mode that allows them to analyze a new application before implementing zero trust policies. But what if you're using devices that have no management capability? Think of the explosion of IoT inside of an organization now. Most industrial IoT devices are very simple in nature, and putting former IoT devices like manufacturing equipment onto the network through the use of gateways doesn't afford us much more control. And that's where device profiling comes into play. So for users and for manageable systems, zero trust is the way to go. For IoT devices or non-managed things, you really should be looking at device profiling, which is essentially allowing your network to make decisions about the IoT device and create a kind of zero trust security. So we go all the way back to everyone's favorite hack from Target years ago when their point of sale system was used as a vector because it was talking to the HVAC system when it shouldn't have been. Device profiling would allow a security team to say, this device should never, ever have to talk to this other device, and we're going to create policies that disallow that from happening. Okay, well, that works. That's great. We can create policies all day long that say things are not allowed to do one thing or the other. But what makes this different? Well, that's the second part. Remember how I said that zero trust is continuous monitoring? Trust but verify. You have to trust these devices, but you have to believe that they're doing what they say they're doing, which means you have to keep an eye on them. And so that's one of the things that we've taken away from the SolarWinds attack. When the actors responsible set this up, they did so months in advance. They created the environment to turn this code on, but they didn't do it right away. We don't know what they were waiting for. Were they waiting for the right time? Were they waiting to make sure that they weren't caught? So the lag time between the intrusion and the activation at this point is several months. We're according to some researchers, we're looking at December 2019 for the initial infection. March 2020 was when everything got turned up and turned on, essentially. Zero Trust keeps an eye on these things. Zero Trust says, hey, this application used to do these things, and then it started doing this other thing. And I'm not sure if that other thing is something that it should be doing. Can you take a look at it? And that's where human beings still have to be involved in the loop. Machines are really great at giving us tables and enumerating things like IP addresses, domain names, port numbers. But they're just listing what they see. They have no context around this. Sure, machine learning and AI are getting better about noticing anomalous patterns in communications. And let's face it, they're better at recognizing those than humans are. But humans still need to provide that context. So should a monitoring system be able to talk to all of the devices in your network? Yes, at least the ones you want to monitor. Should they be able to talk to all of the devices in your network on every port? No. Should the monitoring system be able to talk to the company's servers to get updates? Yes. Should the monitoring system be attempting to exfiltrate gigabytes of data out of a VPN tunnel that terminates in a different country? That's probably a no. And that's where the humans can step in and go, this needs to be fixed, but also we need to find out what's been going on. Far too long we have spent in our careers just assuming that the controls that we've put in place are going to be good enough and we can walk away from them. Let's be fair, as IT folks, we've spent more time fighting fires than we have building firehouses. But those times have to change, because with the amount of compute resources and the amount of expertise that's being brought to bear in these kinds of attacks, we can't afford to just throw a control in place and hope that it works. We can't afford to purchase some new device from a vendor and hope that this is the magic box that will solve all of our problems. We have to plan better. We have to put proper controls in place, and then we have to keep an eye on those controls. Because any good firefighter will tell you that if you can catch a fire when the alarm goes off, you have a much better chance of putting it out than if you wait for someone to point out, hey, it looks like something's on fire. Zero trust security gives us the kinds of alarms, but it also allows us to build systems that are much more fire resistant. When you look at the design of a modern building, we have things like firewalls in place to prevent fire from spreading between large sections. I mean, that's literally where we got the name firewall from, referring to the security device. So we should be using technologies like zero trust security to help us build these things. Now, who are some companies that are doing zero trust security today? Well, almost everybody is. You can look to some of the major vendors, Palo Alto Networks, Cisco, Juniper. You can also look to some of the smaller vendors who are very focused on specific skill sets. Companies like Illumio, Guardicore, Edgewise, who was recently purchased by Zscaler. These are all companies that I've had experience seeing in action, and they all have a different, unique take on it, using different combinations of virtual switches inside of virtualization environments, host-based firewalls, and even packet interception techniques. But the key is that even though they all do it differently, the outcome is still the same. They're still trying to protect your users and your devices and secure the communications while still allowing your users to work. So as you walk down the path of zero trust security in 2021, keep an eye out for the systems that closely align with the types of devices that you want to protect, systems that allow you to ramp up quickly and deploy in pods rather than having to turn it on in the entire company all at once. And finally, look for systems that are capable of giving you reports on a regular basis, but also alerts, so that when something acts outside of the zero trust policy, you can find out about it quickly. Because there are a lot of people right now in the industry who really wish they probably would have been paying attention to those alerts that kept firing when their software started talking to things that it shouldn't have. That should just about do it for this episode of Tomversations. Thank you very much for tuning in. We have an entire season of Tomversations episodes from last year that are available on our website at gestaltit.com. You can also check out our YouTube channel at youtube.com/gestaltit video. If you're not already subscribed, please do so. Hit the notification bell so that you'll know when the next episode of Tomversations comes out, along with all of our other great series like Checksum, the on-premise IT roundtable, and utilizing AI. Please make sure to tune in next month for another great episode of Tomversations. And if you have any topic ideas or technology areas that you would like to have a conversation about, leave it below in the comments, and we will make sure that we get that on the calendar.